So right here what we see is an exothermic reaction or an exergonic reaction. Remember, we have energy here and then the course of the reaction. Now here are reactants and here are products. So let's say our reactants are over on this side, and these two spheres here represent a molecule. Now what we're going to do is break the bonds between these two atoms here, break the bonds of the molecule, and what we're going to do is use activation energy to separate the bonds, and we're going to release energy into the exterior system, or the system outside of these two bonds. When that happens, well, our products, once these are released, have less energy than they initially had. So we can see by doing this, what we're doing is releasing energy, and that energy can be used maybe somewhere else in our body. This is how ATP works, and when we talk about ATP and mitochondria, this is really important for us to understand. But in an exothermic or exergonic reaction, we're releasing energy into the system, and that energy then can be used for something outside of these molecules here. Now, in an endothermic reaction or endergonic reaction, this is a reaction that involves the net absorption. So what we're doing is we're taking energy from the system when we're talking about our reactants. And our reactants have lesser energy than our products do. Remember, over here, these are our reactants. And in this case, what we're doing is putting energy, bringing those bonds together, and we're creating a molecule or a product that has a higher energy level than our reactants did. So in this case, we're taking energy from the system, putting it into this bond, so maybe we can store that energy, use it as potential energy, and maybe use it later for something important. But when we're talking about endothermic or endergonic reactions, it's a reaction that involves the net absorption of free energy from the exterior of the system, or the system that we're talking about. So when we're talking about a catalyst here, what we're talking about is something that's going to reduce the amount of energy required to go from reactant to product, and it's going to increase the speed of the chemical reaction. So what a catalyst is doing is essentially changing this graph, reducing the activation energy, and therefore we can get to our product faster because we're only expending this much energy as compared to this much energy. Therefore, the chemical reaction's going faster. An enzyme's just a biological catalyst, so it's just a protein that's allowing us to go from reactant to product in a faster pace or a faster chemical reaction, and reducing the amount of energy needed to do that. And that's important because it's making sure that our body's efficient and we're using the energy that we have the most efficiently and allowing us to adapt to the environment and react with our stimuli.